testing, testing, testing. Testing, testing. Hi, sorry. I'm so sorry. I'm so sorry. I'm sorry. The other class kept asking me questions and I lost track of time. Yeah, okay. So this is the review class. Again, I apologize for my tardiness. It's unacceptable. I lost track of time. Super sorry. So yeah, so this is a review class. I will review topics that have occurred in this course. If anybody has any requests for topics to review, we'll have those happen now. Thanks for the like, whoever just liked the video, despite the fact that I was 5 minutes late with the stream. This is the right thing, right? Could someone post here to, yeah. I got a new router. I still had that I still had that problem with the stream in the other lecture, but you know. Sorry, guys. Greetings, Omar. There's an announcement, which I'll probably repeat at one point, because we don't have a whole lot of people in the stream right now. But if you check the announcement feed on Avenue, I've extended the deadline for assignment 5 one more day. One more day. Tomorrow is the last day of classes, and I'm not extending the assignment 5 into the exam period. Time to wrap it up. Hello, Ethan. Yeah. So, sorry about it being late again. I was talking to the other class and they kept having questions for me, and I got really into the questions, and then it was like... So, to recap, today is a review stream. So if you have any questions about any of the material that we've had in the course so far, I will be happy to go over the material for you. This is like a student-directed thing, so, yeah! Send me your questions. Oh, shit. Okay. Are we back? Have we re-established connectivity? Hello? 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 How is the stream doing? Is it doing okay? I hope so. Are we back? I think we're back. So, question. Could I give some advice on how to study or prepare? Good. Hi, everybody. How to study or prepare. Where can you find practice problems to solve, ideally with solutions as well? So, all very fair questions. How to study. So, you may have noticed that over the course of this course, the overwhelming majority of the marks that are being attributed to, that are available for you guys during assessments are coming from you guys writing code, right? So you can assume that this trend is going to continue for the exam. Full disclosure, I haven't set the exam yet. I have the exam for 1MD3 on Thursday of this week in 2 days, and I'm going to get that one prepared and out, obviously, before I get to having the exam for you guys prepared. So I'll be doing that. I'll probably be starting on it Friday. So, you know, I'm talking about an exam that doesn't exist yet, but you can bet that preparation for the exam, a good preparation for the exam would be attempting to write programs that solve problems. As for where to find practice problems, there are a number of sites that you can get. W3 resources, C pointers, for example. I think W3 resource is like a good source for, C programming exercises. For loops, arrays, pointers, linked lists, strings, all kinds of stuff. Recursion even, file handling. Ooh, that's cool. File handling and recursion. So these are practice problems. Looks like you can see the solutions to them as well. So that seems to be a good. I've recommended W3 resources to people before. Generally speaking, it's not like it'll auto grade your. It won't produce automatic feedback for you about what you got wrong on your program. For example, codingbat.com. It's not for C though. It's for Java and Python. But the other thing that you could do is you could do some of these problems in C rather than in Java or Python, and that would also be good practice. But I think W3 resources hits more of the categories that we specifically covered in this course. So this is what I would recommend, and I'll put the link in the chat for you. So bloop. There you go. So hopefully that answers your question. Could I go over the format of the exam? How many questions? Is it starting the 22nd at 7:30 like it says, or will it be on the morning on the 22nd? Good questions all. Thank you, Jacqueline. So the exam will be handled in the precise same manner as the test was handled. So the format for the test is the same as the format for the exam. So that means you will have a 24-hour window to be able to write your exam in. You have an unlimited amount of time to write the exam within that 24-hour window. You are permitted aids, such as the lecture slides and documentation on the internet. You are not permitted to exchange your answers with anybody else. No plagiarism, no academic dishonesty, please. It's a take-home test, but that doesn't mean you can plagiarize. As I'm sure you guys know, because you're second-year students, and you've probably heard the rigmarole before, but it bears repeating. But yeah, the exam will open at 9 a.m. on the 22nd, and it will close at 9 a.m. on the 23rd, Christmas Eve. So you'll have the 24-hour period to write it in. Same drill, exact same drill as the test. However, because it's an exam, you know, you can expect it, A, to cover topics from throughout the course, and B, to cover, like, it's going to be longer because it covers more material, right? I don't know specifically how many questions there are. I don't know, it's probable that there'll be another multiple choice section, just because, like, there's a certain amount of it that's the easiest way to do it. You know, there's certain things that have to be covered with respect to the reporting requirements, so, you know, there might be some multiple choice in there. Multiple choice when it's an open book test is kind of lame, in my opinion, but it is what it is. This semester is what it is. But yeah, hopefully that answers some of your questions. Will file I/O be on the exam? Well, we did have a topic on it, right? And I don't believe that ended up on any assignment or test. So let's take a look. I think that was topic 9? Nope. Topic 8? It was in there somewhere. Preprocessor and miscellaneous errata. This was a short one. Yeah, so I'm not going to rule out anything as being not on the exam. However, I'm not going to be... I don't think that you will be unreasonable. Like, you don't have to expect, like, an unreasonably long C++ question involving classes. Like, there might be something on there, but it won't be, like... It won't be a monster question, you know? The exam will focus on the focus of the course, which is C programming. But yeah. Will we be allowed to use Piazza like in the previous test? Yes. Just like in the test, Piazza was the mechanism for you to raise your hand and ask the TA or the professor a question during the test. That's the replacement of that functionality that you would typically have available to you during a regular sort of test or exam. So this is the replacement for that for this course. So, yes, you will be able to use Piazza. Please do not post any of your code when you're asking questions publicly, because that's academic dishonesty. Posting your solution to an exam question during an exam on a public forum or in a public manner, that is academic dishonesty. However, if you put it into a private question, which is only viewable by myself or the TAs, that's a different matter. So if you need me to actually look at your solution, please do it in the form of a private question, which should be reasonable. Could I briefly explain MLOC and why we need to free, as well as what Typedef does with respect to structs? Also, if possible, an analogy would be helpful. Yeah, sure. So, let me pull up the slides where we talked about MLOC. I think it was in pointers. This was strings. Pointers was topic. Boy, pointers was a while ago, eh? That was like before the break, or after the break, or something. Anyway. MLOC. So MLOC is dynamic memory allocation, right? So this is what's going on. The way that your operating system handles memory allocation to programs is that somewhere within the guts of your operating system, there is a table that's being maintained that correlates process IDs to regions of memory that have been allocated to them, right? That's a table, you know? What the malloc command does, it's like a system command, is it requests that the operating system allocate a certain amount of memory to the process, right? So, let's say you make an MLOC command and you request 256 bytes, right? The operating system receives the request for 256 bytes, and it says, it scans through its own memory using this table and says, let me see, where do I have 256 bytes I could give you? Where do I have that much? Here it is, in sector 3748B. So it then returns to your program a pointer to the location in memory where it has enough space to be able to give you that, right? It registers that that memory has been given to this program inside of the table of allocated memory, right? So, that's how your program gets that memory. And this goes on, a lot of this goes on behind the scenes. Like whenever you're allocating a variable, the same deal applies, basically. So that's how you get the memory using malloc. And calloc is very same, and realloc is just a free and a malloc with data transfer between the two. We'll talk about that after we talk about this. But yeah, your question has been registered. So that's how malloc works, right? Free. What free is and why it's necessary. So if you think about this table, the operating system does not consider itself responsible for freeing up all of the memory that's associated with a certain process ID when that process closes. It's the process's responsibility to request that the operating system free the memory that's been associated with it. That's what the free method, or the free function, is for. So when you call free and you give it a memory address, basically the operating system receives that command, it looks up in the table for the memory address that has been given to the free command, and it says, okay, let me see. There it is. So that was given 256 bytes in this particular sector. Okay, I'll just remove that entry. That memory is now free. It can now be reallocated to another process. So basically, all free is doing is it's deleting an entry in that table. It just looks up the entry in the allocation table by the by the pointer, and it deletes it. So when the operating system is looking through the table to see where the unallocated memory is, that memory was no longer blocked out. So that's freeing it. Hopefully that is that a sufficient description? Hopefully that's a sufficient description. What does Typedef do with regards to structs? That's a good question. So when you make a Typedef, all you're doing is you're creating a type synonym, right? So if we go, I think we covered this in, where was it? Structures. Typedef. No? Maybe it might help if I spelled it correctly. No? Where's struct? Struct! Let me find an example of it. Yeah, here we go. Good. So with respect to structures and typedefs and how they interact with each other, The typedef statement can be used to create a type synonym for any type in C, right? Often in C, you'll have a bunch of, tags associated with data types, right? So when we're creating a structure, we're creating a new data type. It's a compound data type. However, it's a requirement in C that the tag struct prepends the name of the structure in all cases, right? It's kind of like unsigned. In some languages, if you want an unsigned integer, you type it like uint, right? In the case of, you could write a typedef that was like unsigned int and uint, and then you could just use uint throughout your code like it was, like that's what it was called. It's a precompiler step where the compiler will trace through all of your code and replace any instance of the last identifier with everything between the last identifier and the typedef. So it's kind of clumsy to write struct every time you want to reference a structure type, so you can just rename it to customer with a capital C, and then you don't have to type struct customer. You can just type customer with a capital C. So there you go. Hopefully that makes sense. Typedefs are pretty easy to, conceptually they're not that difficult. It's very similar to a macro definition. Okay, so Omar asks, for operator overloading, is it overloading or overriding? Because during lecture you mentioned that it is overriding. In the lecture slides it's overloading. So I believe in the lecture slides I said, what do you guys think? It was like a question to the audience. Let me just pull up the lecture slides. So there's a difference. So first of all, let's review the difference between overriding and overloading. So when a function is defined multiple times for multiple type signatures, it is overloading, right? C++ goes through a process called overload resolution, which selects the correct function definition from the available function definitions by examining type signatures, right? Not including return types, just including arguments, right? So the overloading, that's what overloading is and does. Overriding means providing a new definition for something that has been defined in a base class, right? So if you have a class which is a derived class, and you have a derived class that inherits from a base class, if you have a function that's defined inside of the base class, and you want to provide some new definition for it, some new functionality to that method, you can override the inherited definition. The restriction on overriding is that the type signatures must be the same. So in overloading, you have distinct type signatures for each definition. In overriding, you have the same type signature for each definition. It's resolved according to which class, what the class of the object that's it's being called on is. I know that's like a roundabout way of describing it, but I think it's the best I can do. So in the case of operator overloading, and it is overloading, when you redefine what an operator does for a particular class, okay, so it can be both, but in the basic instance, so let's talk about the base class in our derived class, base class example. Let's imagine that we want to redefine what plus means for complex numbers, for instance. This is an instance of overloading. It's overloading because we're taking the function, which is plus, and we are introducing a new type signature. It's a new type signature because C++ will not come with any definitions for plus for any class that you've invented. That just makes sense. How can it know what you've invented, right? So this is overloading plus so that it also works with the complex type. Now, where it becomes a little more complicated, let's imagine that complex is the base class for another class. So let's say complex fractions. So we just have complex numbers, but now they're fractions, right? Complex fractions inherits complex, right? Well, maybe this is more of a compositional case, but anyway, the class that inherits from this one may choose to override the definition for plus that has been provided in the base class. In this case, we would be overriding a function that is overloading the base, like the prelude definition of plus. So you can do both, but if it's this instance here, this is just overloading, not overriding. Does that make sense? Hopefully that makes sense. I'm still streaming, right? This is still coming through? Cool. Yeah, cool. So, are there any other questions? I guess I never properly answered, will file I/O be on the exam? Again, I haven't written the questions yet, but that is, like, that's a highly testable type of thing right there, you know? That's a highly testable type of thing. Fortunately, it's not that difficult, especially when it's an open book exam. I know you said you haven't written the final yet, but how much do you think will be C assembly and C++? So, there has to be one question on assembly. There has to be one question on C++, although I may choose to do multiple choice for that one, I'm not sure. It'll either be a reasonably simple programming question for C++, because obviously we didn't focus on C++ through this course, or I may choose to do that as the multiple choice questions, I don't know. But one question assembly, one question C++, the rest is C. That'd be the rough breakdown. Can I talk about binary trees and the depth first search? Yeah, I could totally talk about that. That's in data structures. Trees! Support the Arbor Day Foundation. Yep, and then we can do stacks. So trees. Trees are a data structure. The binary tree is a particular type of data structure because each node in a binary tree will point to at most two other nodes, right? It has at most two children, each parent. This distinguishes it from something like a trinary tree, which would have three. Generally speaking, binary trees are used because they're like good enough in most situations. You don't necessarily, like, you know, binary trees, binary system, it's all binary at the end, right? But anyway, so So the binary tree, in terms of our definition of graphs, it's an acyclic directed graph where each node may connect to at most two others. But yeah, it's, you know, in terms of the structure that this corresponds to, and I realize I'm helping you guys out with assignment 5 right now, but, you know, with respect to the structure that would correspond to each of these nodes, in the same way that a linked list is composed of a bunch of data structures that point to each other, right? Basically, if you take this guy and you have a right and a left pointer instead of just one next pointer, you have the nodes of a binary tree. Simple. With respect, yeah, if it were, yeah, like when you're looking at these diagrams, each arrow is going to be a pointer, right? A pointer to another another node, another instance of the node structure. So, yeah. The question on the assignment is, I think, you know, I didn't think it was too bad because I didn't actually ask you for like I believe I didn't ask you to construct one. You just perform some operations over one. And constructing them is like a little bit on the harder side versus just traversing them, in my opinion. But, you know. So depth first search, right? The depth first, this summing algorithm is actually using a depth first search. It's using a depth first algorithm. It's not searching, it's summing, but like this is the order in which things will happen if you're doing a, roughly speaking, if you're doing a depth first search. In the search, the one that's in the assignment, I'm examining the node that you're on first to see if. Hello? Are we back? Hello? Cool. Alright, where were we? Depth first search. Yes. So, the depth first search is exactly what it says it is on the box. When you perform the depth first search, what you do is you follow a particular branch of the tree down to its extremity. If you don't find what you're looking for, you backtrack to the previous level, or you backtrack until you find a branch that you didn't try. You then try that branch until it reaches its extremity, and then you backtrack again. The algorithm for this can be encoded in a decision algorithm for each individual node, and it's the same decision algorithm for each individual node. So in general, I would consider depth-first search to be a good candidate for a recursive implementation. So yeah, that's depth-first search. I'd like to get to the other question, which is about stacks. So stacks were something we covered way back at the beginning of the course. And, you know, there was that question on the test about them. Generally speaking, they make more sense once we have structures. Generally speaking, you won't bother setting up a whole stack just to store numbers, such as this one. But generally speaking, a stack is also known as a last in, first out buffer. So you have a buffer, or you have an array in which you're storing things, and you have an operation that adds things to the array, and you have an operation that removes things from the array. You're not just randomly accessing any particular element in the array, you're accessing, like, the means of access to the array is controlled. In the same way that, I've been banging on about controlling access to the data and enforcing data policies in C++, this is a similar type of idea. So when you push something onto a stack, that is adding it to the stack. It's like a stack of plates. It ends up, when you push it onto the stack, at the top of the stack. So if you were to perform a pop operation immediately afterwards, that's the element that you would get. And once you have popped something from the stack, it is removed from the stack. So, so as to expose the other things in the stack. It's like a stack of cards. Once you've drawn a card from your deck of cards, that card is no longer in the deck of cards. But yeah, stacks are used all over the place inside of your computer. So yeah. How do you use a stack? Well, you just use it by accessing the methods that I've just described. Actually, that wouldn't be a bad C++ question right there. Anyway. Are there any more questions? I'm still streaming, right? Yes. Well, I guess this more or less concludes the course. Thank you very much for your time and attention this semester, folks. This has been fun. I know we kind of had this discussion already in the previous lecture, but yeah, this has been fun. It bears repeating. Cool. Well, Okay. Yeah. No trouble. Yeah, I think it was. Hmm. Cool. GG. GG no re. Hopefully. Alright. Well, take her easy. It might be useful at some point to schedule another review session, like closer to the exam, once people have had a chance to study. So, yeah, keep your ear to the ground about that, and we'll see how it goes. Maybe we'll have another review session, like the day before, or the day before the exam or something. But yeah, all right. Take her easy, folks. I hope that you all have a good exam period. Good luck on your exams. Try not to freak out too much. But, yeah. You got this! Don't let me down. See you later, folks.